Hey everybody, this is our lesson on properties of solutions, and by the end of this lesson, you should be able to summarize the properties of solutions. I would suggest though, before you get started, just pausing the video here and reviewing homogeneous mixtures and endothermic and exothermic reactions. So first, there's just a couple definitions that you need to make sure you're aware of before we get too far into this. And the first one is a solution. So a solution is a homogeneous mixture composed of solute and solvent. When we look at a solution, it doesn't just have to be a solid dissolved in a liquid or an aqueous solution. It could be a gas dissolved in a liquid. It could be another liquid dissolved in a liquid. But it just means you have two mixtures that are coming together that when they are mixed together, they look like one substance. So now that we know the definition of a solution, let's break it down a little bit further into solute and solvent. So solute is what is being dissolved. So in this GIF here, it's the powder that's in the bottom. And then the solvent is what's doing the dissolving. So that would be the water here. Water is actually known as our universal solvent because it does dissolve a lot of compounds down based on all the properties that water has. So now let's talk a little bit about solutions themselves. And when we form a solution, it's because the attractions between the solute and the solvent are stronger than attractions of the solute particles to themselves or the solvent particles to themselves. So if the attractions between water molecules in the solvent are stronger than the attractions between water and whatever it's trying to dissolve, it won't dissolve it. The water will stay intact. Or if the solute molecules are more attracted to each other than to the water, they will not dissolve either. So when we do have a dissolution occur, there are a couple other terms to look at here. So the first one is electrolyte. An electrolyte is a salt that breaks apart into ions when in solution. So think like Gatorade. We have non-electrolytes, which means it's a substance that does not break it up into ions in solution. So these would be like sugars. We have miscible solutions, which means they can mix together any proportion. So an example of this would be water and alcohol. So certain like rubbing alcohol that you get at the store, you can get 50%, 70%, 90%. So that's how much rubbing alcohol is dissolved in water. It will continue to dissolve, which is why we can have different percentages there. And whichever one you have the most of is what would be considered your solvent there. So in 90% rubbing alcohol, that means it's 90% rubbing alcohol, 10% water. The rubbing alcohol would be the solvent there because you have more of it. And then we have a term immiscible, which means it will not mix together at any proportion. So a good example of this is oil and water. You know, when you put those two together, oil will bubble up on the surface. And now let's quickly talk about the factors that affect solution formation. There are three to be aware of here. So the first one is stirring or agitation. They're the same thing. And this, when you stir, as you can see in this GIF here, you're allowing new solvent molecules to come in contact with the solute to allow that surface of the solute to dissolve. You also can look at particle size because the smaller the size of the particle, the more surface area that's exposed, which means it's easier to dissolve. So I like to say if you compare a sugar cube to crystals in a sugar packet, the crystals are much smaller, more of their surface area is exposed, so they will dissolve faster. Whereas a sugar cube, you can dissolve the sugar crystals on the outside, but on the inside, there's more sugar crystals that you have to dissolve. And then you keep working layer after layer. And then the last factor is temperature. And when you increase the temperature, this allows your more solute to dissolve because the water particles are moving faster, which allow for more collisions. I've highlighted these top two because these only affect the rate at which something dissolves. So this only affects how fast or slow something will dissolve. But once it reaches a certain capacity, it won't dissolve anymore. So if you've ever tried to put like sugar in iced tea, you'll notice a lot of times the sugar just kind of settles at the bottom. That's because as much can be dissolved at that temperature at that time. Temperature, though, affects